Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our CO2 sequestration model learning. And in previous video, we have shown the visualization of structural trapping. Okay, we run using gem and we do some modification before running on the gem. We just do a direct modification on the script, and then after running on the gem we open the result using visualization, using this result file. Now we go back to builder and we will add more trapping. To be specific, we will add hysteresis trapping. Okay, so the purpose of this exercise is to add to the structural trapping of the base model by incorporating hysteresis trapping or residual trapping. This trapping method uses the effect of shifting from drainage to imbibition relative permeability curve to trap the non-wetting phase, in this case the gas, the CO2 gas, which actually exists in supercritical condition. Okay, so here we will add to the base case, and the base case is of course this exercise one structural dot dat. We just drag it and drop it on the builder. Okay. All right. So now we are inside the builder. Let's look at our model in 3D view. Here you go. Okay. And now first go to input output control, IO control. Okay. And click on title and case. Here, case 2A, we change it to case 2A, structural plus hysteresis. Okay, so there will be hysteresis in this model. We shift from drainage, relative permeability curve. Drainage means the non-wetting phase displaces the wetting phase. In this case, the non-wetting phase is, of course, the CO2. It displaces the wetting phase, which is water. And we have change in the relative permeability. That's why, because we have hysteresis here. And the shifting is from drainage, okay, to imbibition. In imbibition, the wetting phase displaces the non-wetting phase. In this case, water displaces the CO2. So water will again, the water will displace, water will push the CO2 plumb and will try to occupy the pores back. And when the water imbibe, when the water wants to occupy back the pores, some CO2 will be left behind. Some CO2 will be left behind. That's why we call that residual CO2. The residual CO2 is trapped because of the hysteresis effect. All right, so now we will add hysteresis in the rock fleet section. Hysteresis can be added to the data set by invoking the option in the builder. Okay, before that we click on OK. Okay, hysteresis can be modeled for capillary pressure curves, for oil, water, or for oil gas, or for relative permeability curves, for gas or for oil relative permeability. So we go to here, rock fluid section. Okay, we have rock type 1 here. Okay, rock fluid option. We can review, just review stones, second model. Okay, cancel. And then edit rock type. We are now inside the rock type 1. Okay, here we have rock type properties, relative permeability table. Okay, this is our table for water, oil, and for gas, liquid. Yeah. Okay. And then to activate the hysteresis model, I mean the hysteresis trapping, we select this hysteresis modeling tab and we will enter, yeah, maximum. Let's find it, maximum residual gas saturation of, yeah, model hysteresis effect in, we should be able to find model hysteresis effect in gas relative permeability, should be here, when where we will input 0.4. So you can see here we cannot. So without using this feature in the builder, we will just go to the script and we'll do some editing. Okay, so let's go. I will just close this one and let's go to the script. Okay, so we are back in the folder. Okay, to make it clean, I want to make the second folder. Previously it's structural, now structural plus hysteresis. Okay, let me add something here. Keyword, open. So here. So the keyword is his KRG and the value is 0.4. Okay. Okay, and then yeah, we just copy this dot that and then put it here and then exercise 2A structural plus hysteresis. Okay, we can actually do the modification using cedit, but to make it a little bit different from the previous series of videos, I will just do that in Notepad. So here, case is 2A. Make sure you change this one, hysteresis. Okay, and then we go directly to the relative permeability section here. Okay, and then just place enter and make the keyword his KRG 0.4. Just like this and done. Very easy. Very easy. Click save and close. And then we will go back to the here and then I will go here and touch the second folder, structural plus hysteresis. You can see here, this is our .dat, and then just run it using gem. Drag it on the gem. Okay. And then let's just, yeah, again, yeah, the number of processor 4, simulator version this, and then input file, output file, log file. Okay. Okay. Let's wait. You see the produce results still waiting, still running, schedule local. Let's wait. It's a little bit longer because now it involves hysteresis. Okay, completed. So before visualizing the result using results, let's just review the result here. Dot out. Let's check it out. Okay, so this is the results. Opening with the script. All right. So far, so good. You can see again, supercritical No dissolve in water. That's okay. There is no solubility trapping yet. And here we have trap gas saturation below critical gas saturation or due to hysteresis trapping. Okay. Okay, but of course we will not review everything here. It is much more useful if we just go directly to visualize the result using, using results feature. Okay. Okay, so we will move, but we will first close this video. Thank you so much for watching. See you again in the next video. Thank you.